We're talking about providing light for people to get from A to B. Whether you're a road user or whether you're a pedestrian, you're generally going on a journey in some form. And along that journey, there will be risks associated. So it's key for the human eye to be able to identify those hazards long before an accident occurs. Hello and welcome to Thorn Lighting's Let's Talk Light. Today, Thorn presents the road to better lighting. Key considerations and some top tips. And as you can see from this wonderful background picture here, albeit blue sky thinking going on, we have a really nice scene with one of our products there, the R2L2 lantern, lighting the road perfectly and the associated footpaths for pedestrians. My name is Martin Thompson. I am the Thorn Applications Ambassador for United Kingdom and Ireland. Today, everyone is on mute, but questions will be answered separately beyond the presentation. So please feel free to write directly to me on my email address, the bottom left-hand side of the page there, martin.thompson@zumtobalgroup.com. We have an exciting 4 weeks ahead of us. Today, we start with key considerations and top tips with myself, but in 1 week's time we will be going over to Dan Pars, who will deal with your route mapped out, dealing with 5 application areas and other topics. And then in 2 weeks' time we have Peter Thorns, who is going to deal with introducing the RPEC optical system to you all, and he's going to be accompanied by Maxime Perdue, one of our optical designers. And then in 3 weeks' time we have Valdemar Becker, our global product manager for outdoor lighting controls, who's going to talk about all things Zaga up, Zaga down, and Zaga drivers, and Zaga control systems. And then in 4 weeks' time, we're going to have Valdemar back to talk about our central management system, UrbaSense, which deals with the larger outdoor lighting control systems. So for today, I talk about the way forward. The first word I will say, and I will repeat, is safety. We provide artificial lighting in outdoor areas for safety, first and foremost. It has to be top of mindset for anyone involved in the process of delivering road lighting to the public environment. So that includes manufacturers, it includes designers, it includes consultants, and indeed it includes the end client, because the end client should really look at their own spaces and should talk to their own people about what they want. And there's pockets around Europe that are engaging with the public to decide what is best for their environment in terms of road, in terms of pedestrian and safety. Typically in Europe, we use the common platform for lighting design, which is the European standard EN 13201, normally generally referred to as 13201. And this deals with lighting requirements for road lighting. It also deals with the environmental aspects, and it also talks about energy, and it also talks about testing. So there's a lot that the EN 13201 parts 1 to 5 deal with. Safety, I mentioned first, and I promise safety will always be at the top of the agenda. So for people, predominantly we're talking about pedestrians because they are more vulnerable than someone behind the wheel of a motor car, or indeed on a motorcycle, or indeed a cyclist, a lorry, a bus. All of these people are much safer than the pedestrian. So the most vulnerable person would be a pedestrian. And I talk about people, but it's also about animals. It's also about the place itself, the environment. We talk about the whole aspect when we're actually doing a lighting design for a road. But in terms of the people, people walking along a street need to be able to be aware of what's going on the road, and vice versa. The road users also need to be aware of what's going on around them in the place itself, but also in particular on the adjacent footpath. And we mustn't forget, the environment. Right now in the world, you'll have seen the global conferences taking place on the environment and what we're going to do collectively as a human race for the planet. So it's crucial that when we're designing our products, we design for the environment as well as the people, as well as the places. And the technology that's available to us now allows us to do much more environmental work than ever before. And the technology is there. So it's right now we need to do these things. Some of the key facts, when we're talking about the road lighting, what are we actually talking about? We're talking about providing light for people to get from A to B. Whether you're a road user or whether you're a pedestrian, you're generally going on a journey in some form. And along that journey, there will be risks associated. So it's key for the human eye to be able to identify those hazards long before an accident occurs. So the road lighting is definitely there as a preventative measure to accidents occurring. And of course, it's the amount of light used, and we talk about light pollution and the environment again. So if we can do this safely and at the same time decrease light pollution, we've got towards a great actual road lighting scheme. And of course, when we get to high speed roads and we've got people moving quickly, eyes and brains moving quickly at high speed, it's the ability to navigate under those pressures. So things like road markings, things like road signage and other road users are key for the eye and the brain to work, sometimes with split-second actions. And it's very, very key that everything is highlighted perfectly for the eye to allow the brain to work quickly, to allow the body to then change direction and change actions as required, again, to prevent accidents. So when we talk about road lighting and the peripheral vision, I take this picture on the bottom left here where we've got a cyclist happily driving along, and we've got a pedestrian that's obviously about to go onto the pedestrian crossing. And on the right-hand side, in the peripheral vision, we've got two pedestrians, both walking towards the pedestrian crossing. So the cyclist has a couple of questions here to answer, really. Is that pedestrian going onto the pedestrian crossing? Yes, he is. I'm going to slow down. By the time I get there, that pedestrian will have crossed the pedestrian and be on the other side of the road, and then I can carry on my journey. Or indeed, is the pedestrian going to achieve the pedestrian crossing area before I get there? Do I need to start slowing down now, or can I get across that before the pedestrian arrives? It's all these seconds of decision making that the eye needs to make with the brain, and the good quality lighting that does not just the road in this case, but it does the surrounds, nice big wide footpaths, parks to the left beyond the actual road area, and off to the right hand side you've got the buildings and you've got the promenade there, perhaps with shops. You can imagine two scenes here, one scene with a fully packed low peak winter's evening or high peak winter's evening. In the high peak, the streets will be packed, the vehicles will be going a little bit slowly, but there'll be a lot more activity to think about for the eye and brain. And as the evening goes on into the middle of the night, you might get a scene as we depict here with just the odd person, you know, in the scene to think about. And then when we talk about, you know, the actual flip side of the coin from the road user to the pedestrian also has responsibilities. So as they come onto that pedestrian crossing in the top right hand corner picture there, they have to think about that road user. Has the road user seen me? If not, just pause a moment to verify that situation. If they haven't seen you, stay where you are, allow the road user to carry on across the pedestrian. If they have seen you, that pause has guided the road user with the eye, with the brain, to stop the motor vehicle, and you can cross safely. And we can't go across any key facts without talking about cost saving and sustainability of the lighting scheme. So a lot of big schemes do require fast return on investments. So you've got to think about having a really good sustainable lighting offer, but also a cost-effective offer at the same time. And eco-friendly products, we talk about the life cycle of products. So you try to recycle as much of the materials at the end of life as you possibly can to reuse those materials. And for 10 years now in our company, we've used EPD, which is short for Environmental Product Declaration. And the eco-friendly side of that product is all highlighted right from the very birth of the product all the way through to grave. And of course, at the end of all of that scheme, we need to reduce energy consumption. So it's going from a typical scheme of, let's say, 150 watt lamp, perhaps, with best case conditions with an electronic ballast, you could be looking at 165 watts of energy being consumed. In the modern lantern environment with the technology available, that can easily be brought down to circa 50 watts or less. So you're saving easily between 50 and 75% energy just by changing the lantern. If you then go on to use controls, you can actually reduce that energy even more. Energy is a key part of any major installation that we talk about. But the other major that I believe in is the obtrusive light side, and making sure that the products that we put into the marketplace for a particular lighting design do not impact on people and the environment. 3 typical phraseologies used are spill light, sky glow, and light trespass. So if I can just point my cursor up here towards the sky glow side of things, this is completely wasted light, and worse than that, it's going directly up into the nighttime sky, affecting everyone else's enjoyment of the stars at night and those dark skies. And the second one, most I guess appropriate to residential, is people in their own homes getting this sort of light trespass directly from the lantern going onto the ground floor here. So you can imagine a residential user being nicely sat in their living room, comfort, they've had a hard day at work, and the last thing they want to see out their window is a direct view to the point source of an LED lantern. So you must think about controllability of that backlight when you're designing a product. And then this upper echelon here of the light trespass into the first floor, you do not want the nighttime event in the first floor to be disturbed by light trespass. You want dark rooms for quality sleep at night, people's circadian rhythms to be balanced, and people have long and healthy lives. And productive daytime only becomes as a result of good quality nighttime sleep. And then finally, the boundaries here that we show in different areas. So here you've got the main part of the reference area that we're actually trying to light by the design under EN 13201. And then we've got the immediate surrounding area where there might be an element of light required, just up to this red line here. And then you've got the surrounding area where probably you don't want light, and where you most definitely don't want light is the spill light area. And here we have light going outside the beyond the boundary of the lighting scheme itself, completely wasted spill light, completely wasted energy, and this is something you just should not do. Just for those amongst us who might not understand some of the abbreviations here, ULOR and DLOR is dealing with the upward light output ratio of the lantern itself. And ideally, you do not want a lantern here, for example, to be tilted. You want a 0 degrees mounting height if you can, to deal with. And let me show you a couple of pictures which depicts that a little bit better. So here you've got in this bottom left-hand corner, you've got this lantern here, which is at 0 degrees tilt. And here you've got a lantern at circa 5 degrees tilt. You can see the light pattern is changing. This is sending more light higher and across the road, so you're going to get spill light with that. And this one here is stopping that light. It's putting it right into the design area that you're looking for. And just a couple of examples up here, top left, now we're talking wide beam and narrow beam. And in the RPEC presentation you see in 2 weeks' time, you'll hear about 20 different light optics around the RPEC that can put the light specifically where you need it for the best energy, best lighting uniformity, and best use of light for people and road users. So as I've said, please avoid tilting in your lighting designs. All of our lanterns are designed to go at 0 degrees tilt. If you can get a quality lighting design at 0 degrees tilt, you're doing the right thing. And of course, we talk about less lumen output. So the controllability of the lantern is key in terms of the technology. You can actually control the specific amount of light you need to actually achieve the lighting design requirements under EN 13201. So you save more energy, you use less carbon, and every different design you do in there is a quality design delivered to optimize all of the elements that we talk about when we're doing lighting designs for road lighting. The whole lighting picture will be spoken in more depth next week by Dan Pars. So he will talk about major roads and minor roads, not just residential areas, but also conflict areas, pedestrian crossings and bridges. All of these areas require different lighting treatments under EN 13201. Dan will delve a little bit deeper next week for you, so watch out for that, please, when it comes along next week. And I'd just like to finish this particular presentation with a little bit of a case study. This one was one of our partners, the city of Sunderland in the northeast of England in the United Kingdom, and their project here was around about 27 luminaires need to be replaced as part of their reduction scheme in energy, but also the improving the nighttime environment for the social side of things, trying to get more people out of doors at night, get that social connectivity going, and also the economic growth. So there was a multifaceted brief by the client, and 27 lighting points were indeed changed. And you can see some of the numbers down here. 9,000 tons of CO2 was saved per annum thereafter. And here, this is what we talk about controllability now. We saved an additional 25% of the actual energy used by using nighttime profiles for the council to match the EN 13201, optimizing the use of the lantern. And of course, we used the RPEC optics throughout, and we used multiple RPEC optics to provide different schemes across the whole lighting picture. And importantly for the council, let's not forget, money's heavily involved in anything we do in the world today, and they saved £2.4 million per annum over the last few years as part of this 27,000 R2L2 lanterns that went into this particular scheme. And just a quick look at the standards that we work on. I've mentioned EN 13201. It deals importantly with the selection of lighting, the guidelines. It deals with the performance requirements, the calculation side of things, the methods of actually measuring that lighting performance once you've actually done the scheme and it's installed. And of course, it deals with indicators upon the use of energy and how you can actually change that. And the RPEC optic actually allows lighting designers the choice of optics to save more energy depending upon the area you're trying to light. But we mustn't forget there's many more standards around Europe that we can touch upon. CIE, for example, here with 150, 115 and 132, they deal with the limitation effects of obtrusive light from outdoor lighting installations. They deal with the recommendation for lighting roads, and of course, the design methods for lighting roads, most importantly under CIE. And then EN40 deals specifically with lighting columns and all things structures. So anything we need to look at with respect to design of columns, we can find those regulations stipulated in EN40. And when we talk about EN 12767, we're talking about the passive safety of such support structures and road equipment, where you might want actually a particular, what we call a knockdown. When we see a column being knocked down, it moves away and it actually absorbs the energy. So it's actually trying to preserve life of the driver if indeed there is an accident takes place. What we call an RTA, which is a road traffic accident involving a structure. We talk about passive safety to try and save life. And the final one, which a lot of lighting designers use on a day-to-day basis, is EN 12464, commonly known as 12464. And this one we're dealing here with is part 2, lighting, and it's dealing with lighting of workplaces, which again, part 2 of that is outdoor workplaces. So it will deal with, specific workplaces and outdoor environments that need lighting, such as car parks, for example. So that's it from me for today. So please get in touch. I remind you to write to me directly if you have any questions on this early overview. It's martin.thompson@zumtobalgroup.com. We have 4 more sessions coming up in the next 4 weeks, so please look out for them. They're about the same length of time, 15-20 minutes, snapshots at road lighting. And that's it for me today. So goodbye and farewell for today.